just a few more participants can introduce themselves, which have not introduced themselves yet. So anyone can introduce who have not introduced yet. It's like for your name, institute name, and then your areas of interest. So anyone can start. We'll wait for 5 minutes. Others will join by that time.
Good afternoon, everyone. Am I audible?
Yes, madam.
Yeah. So this is Shubhlakshmi Agrawal, working as an assistant professor in ILM Greater Noida, and my research area includes the ML, machine learning, image processing, and deep learning. So currently, I am working on a project that is student satisfaction. So that is basically we have to collect the face images of students, and we have to just identify the expressions that they are happy or not happy. Yeah.
From the face, you want to recognize their mood.
Yeah.
Okay, great.
So
great.
we want to recognize their, yeah. So we are taking the attributes from the face images and just want to recognize the expressions of the students. Happy. So currently we are working on 2 expressions. So that is supervised binary classification, happy and not happy.
Okay. If they are not happy, then you can play a song, sad song like Mukesh or someone.
Yeah.
And if he is happy, then you can play a Kishore Kumar song for him or her.
Okay, sir. Okay.
Yeah, thank you. Thank you very much, Agrawal. Thank you. Anyone else would like to introduce? So, a motivational speaker was talking to the group, a big group in a hall, and he asked some question, and then no one replied. So he said that the first thing is to grab the opportunity. So you should always grab the opportunity. If you see an opportunity to talk, if you see an opportunity to lead, if you see an opportunity to express yourself, so grab the opportunity. And here there is an opportunity. You have a window. We are stealing this window from the resource person's time. So we have given 120 minutes to them and are stealing their time, and you have an opportunity to express yourself, to tell about yourself. And we are somehow not exploring it. We are not taking effort. We are not grabbing the opportunity. Anyone want to grab the opportunity?
I would be happy if anyone explain me which algorithm they are working on, so that in today's my experimental analysis or lab session, I could focus on that. So anyone, please let me know. Like currently, Madam said she is working on emotion detection, that is mood detection. So anybody else is working on any of the algorithm or something, some research problems you have, then please let me know. Right now, it will be the set good time so that we can focus on that and we could take that as a case study as well.
Yeah, you can talk. You can unmute yourself and talk.
Hello. Hello.
Yes, Shahabuddin.
This is Shihabuddin. I'm from Kerala. Currently, I'm working as an assistant professor in college of teaching and Kerala.
Shahabuddin, do you want to talk?
It's not
You
audible.
want to introduce yourself?
Oops.
Okay, anyone else?
Hello, sir. Good afternoon.
Good afternoon.
See, I'm working on text analysis, text classifications, and I would like to know which model we can be. It's useful to find the accuracy on text based on the emotions. Which model and which algorithms based on.
So are you working on sentimental analysis by any chance?
Which model we can use to specify classify the accuracy of the emotional levels, you know.
So that is a research problem, sentimental analysis. My question is, are you working in sentimental analysis in dictionary mode?
I have just started, but I'm just grabbing knowledges, so have to further proceed for it.
She just want to collect whatever models you can suggest, and then she will work upon it.
Yes.
She can explore it. Yeah. Thank you, Kavita. Anyone else? One more. Would like to speak?
Hello, sir.
Yes.
Yeah. So I'm working on identifying the.
So can you tell your name?
Okay, sir.
And then go ahead.
Myself, Professor Vipul Kondekar from Walchand Institute of Technology, Solapur. So I'm working on application of image processing in agriculture, where by having the images data set of disease images and healthy images, we want to come up with the conclusion that whether the new image which is given for testing, whether it is a disease image or a healthy image, and if it is disease image, then can we calculate the extent of that disease?
For which part?
Leaf images.
Leaf image. For crops.
Yes, yes.
Okay, like that mood that Agrawal madam was telling, it's like same, no? Like leaf, your face is like a leaf, then you are taking whether it is happy or not happy.
Yeah, back end is same, front end is only changing.
UI is changed. Okay, all right. All right. So Mukul is with us. Dr. Mukul, as I have just introduced him, working as assistant professor in IMCC College, IMCC Institute in Pune, and he has a good number of publications. He did certification courses also, and he has one patent also to his credit. Apart from that, he keeps on experimenting with many other things. So welcome Mukul once again, and you can start your presentation.
Thank you so much. Thank you so much, Dr. Manish Joshi, sir. I would first initially thank the complete Kavitri Bhajanaba University for giving me this opportunity, and AICT as well. So I'm going to start. Just give me a minute. I'll just share the screen and then we'll start. In the meantime, I would suggest the madam who is working on the machine learning on text, I would request her to go through NLTK and LSTM. LSTM networks are the most that works on textual analysis of emotions. And sir, who was working on crop disease detection, I would suggest him to study Google's study. It is generally on KD Nugget. KD Nugget is one of the like Kaggle dataset providers, so that will help you definitely. And I hope you can see my screen just a moment now. Okay, so good afternoon, everyone. We are here for the lab session, use case on machine learning algorithms. So without wasting most of your time, we are going to go forward. So generally, machine learning is divided into three parts. You must have already heard. It is again supervised, unsupervised reinforcement learning. In supervised, we generally divide into two categories, or basically we go for classification and regression. and there are sub algorithms for that. So our today's objective in this hands-on is to actually implement some of these algorithms. Okay, so there is a naive-based algorithm which is very primary based on some statistical part. Then there is a decision trees you must have learned. Then there is a SVM, somebody has already explained or informed in Ambuja Ma'am's sessions. And then there's a random forest, KNN, that is what we call K-nearest neighbors. Okay, so I'm not going to go into much of a theory part right now. My objective is to let us be together, since it is a hands-on session, will implement this on simple cases. Okay, so what we have today, I'll give you an overview. So what I have planned today is first we'll understand what is the data processing. Okay, and second we'll see some of the use cases. So in use cases, we have some simple algorithms in the left hand side and some right hand side cases that will apply. So I don't know how many of you are that much technically strong. So I'm going to go from very basic. I'm going to again share my screen. I'm going to basically open Anaconda environment. I'm currently using Jupyter. Okay, and Anaconda. So let me share my complete screen, and I hope you can see my complete screen now. So here, first step is to use Anaconda Navigator. I'm going to open an Anaconda Navigator to start with. I would request if anybody has parallelly set up this, we will do this together. And if you face any problem, we could definitely solve them together. If there is another option that I will be sharing some part of the code, or you can write down that code and as well. So since this is a hands-on session, I would request all of you, if you have set up with you, please do it parallelly. Okay, so generally Anaconda environment takes a small amount of time. If you know how to install this, whenever you install Anaconda Navigator, these are the lots of things. In my personal suggestion, if you are at startup, start with Jupyter Notebook. If you become a little bit pro, you can go to Jupyter Lab for the projects. And if you really want to go into development, either go for Spider or PyCharm. Okay, PyCharm Professional, you require registration, but I would suggest you to use that environment. If you don't have any resources to install it right now, Google Colab, like Ashish sir has demonstrated yesterday, could be the best option. So we are going to start initially with data processing. Like sir said, initially we should know what is data. So let me just share that data. So we'll first understand what data we have. Okay. If you are having an Excel, you can create this data at your place, and then we'll do the experiment. If you don't have that, let me show you how to create a data. So just let me zoom in for you. Okay. So for the first understanding, okay, like Ambuja Madam has already explained, I'm going to go to a simple example. These are data. So these are the list of countries that we have. These are the user age group. These are the salaries of that individual. And these are the result of if we offer a product, whether they purchase based on our offerings or not. Okay, so I'll repeat, this is my data set. So how to create a data set? Open any Excel. Okay, I'm going to create a new Excel sheet for you. Okay, I'm going to create a dummy data. So I'll type a country. Okay, the next parameter you can see is age, then salary, and then lastly purchased. Okay, all of you can type any of the country name. You can take a random between function and take any age group between 30, 50. Okay, same you can write down random between, and you can take any salary between 10,000 to 50,000. Okay, and you can say, okay, yes or no randomly. Okay, every time, let us suppose I take first country as USA, then probably Australia, Okay, there is some, but that's fine. Then China, then Russia. Okay, probably Sri Lanka. Okay, now I'm going to drag and drop this. Okay, then probably yes, no, yes, no, yes. Okay, if you have actual data, this data will look like this. So if you don't have data, but you want to explore and you want to learn data science, I would suggest this way you can create your own data. Okay, so I hope this is very simple. You have created the data. I'll give you some time if you haven't. I'm going to go through Jupyter Lab now, and then I'll share that screen as well. Okay, so I hope all of you are able to see my Jupyter Lab screen. In this, what I will be doing, I will be first telling you how a data process takes place. Okay, so how the data process takes place. Generally, whenever we do any data processing, there are three things that we do. First is we import the libraries. Second, we import the database. Third, we create training and test database. This is uniform throughout. Okay, now we are going to go for some parts. So I would request all of you to do this parallelly. Okay, you may not be proficient, but you can at least start with pen and paper method. So what you can do, please write down the and understand the syntax. First is import. Import is a keyword. Then there is numpy. So numpy is a set of library, and we are importing numpy as np. So whenever we call it, we are going to call it using np. We are going to call it using np. So a syntax is import keyword, then followed by library name and as call. It is called as calling function or call name, or generally we in simple language say it as name. Okay, so this is going to be our simple syntax. This is going to be our simple syntax. Now, everyone, I'm going to go through this code simple one by one. So first, we are importing numpy libraries. Okay, so all of the numeric calculations that we do are using numpy libraries. All of the plottings that we do or graph, charts and everything, for that we require matplot libraries. And for some kind of data manipulation, data operations, we require panda libraries. So there are pandas as PD. So our keyword is NP, PLT, and PD. Once we enter all of this, there's a key. You can select this and click on run. You can select this and click on run. Anybody has any doubt? I'll be happy to solve it or take it right now, because once we start doing this next, it will be difficult for all of you to come back. Okay, it might be a little bit fast if you skip some part. So first, import libraries. Second is importing the database. The syntax for importing a database is dataset. Okay, this is pd dot. Okay, I'll repeat, this is p not dot, pd dot. Okay, so what we are going to do, let me just clear everything. We are going to import the dataset. Dataset, this will be a file name. If it is in the same folder, you can directly give the file name. If it is not in the same folder, you will require to give the path in terms of slash for Windows and this for Linux. Okay, so this is very simple. I hope all of you can do this. Now let me start actually understanding the code and implementing it. So first, whenever you are using Jupyter, you should press Shift Enter. So generally what we do, we reset and clear the output. Okay, so that everything will be reset. First step is importing the libraries. So how we import the libraries? These are the 3 libraries that we have imported. Second, we are going to import the database. So the first step that we're going to do here is import database. Now our database, if you remember, is having age, first parameter. Okay, if you remember, second parameter, sorry, first parameter was a country, second was age, third was a salary. So what we are doing here, identifying based on country, age, and salary, can we predict, can we analyze whether the person will purchase or not? Simple question. Using the parameters or the features like country, age, and salary, can we predict that user is going to purchase our product or not? Okay, so here we are going to divide them into 2 sets. One is called as X, second is called as Y. If you remember in previous few sessions, you must have learned what is dependent variable, what is independent variable. So here, this is independent. Okay, because the country and everything are independent because we are creating them, and they are not dependent. They are being collected, selected, taken as it is, how they are being provided. But Y is instead dependent. Why? Because we are predicting what is Y. Y is nothing but whether a person purchased or not. So Y means decision of purchase is based on country, age, and salary. So 3 parameters: country, age, and salary, 3 parameters. So how we do this? Using this method. So what it means, all rows and all column -1. So -1 means except the last column. So here we are not taking the last column, and here we are taking all rows and only the last column. And what was our last column? So dependent variable was a decision of purchase. Okay, so how we do this? We define X as a set of independent variable. You can select 1 variable, 2 variable, 3 columns. That okay, that is immaterial right now. Machine learning provides you to select n number of variables. So that is not a problem. Now I'll just run the code. So I have created a data set. Now generally we divide the data set into some part. So 70, 30, 80, or 20, these are different patterns. So currently, out of those 10 records, if you remember, there are 10 records. I am taking 8 records for training and 2 records for testing. So how we identify that? By using this. To do this, we have first from sklearn.model selection. Okay, so sklearn is another very important keyword that you should remember. Okay, so what we are doing, like here we import, here we are using a model selection method, and where train and test data has been split into what part? Based on the part that we provide. Okay, and which method we are using. Okay, so it could be randomized, it could not. Okay, it could be sequential. Okay, so here I'm going to just run this code. So what we are doing here, out of these 3 values, okay, out of these 3 values, we are actually converting that data, okay, into 2 parts. So this was my X train data. Now if you observe that this X train data is 1, 2, 3, 4, 5, 6, 7, 8 out of 10, since we said 0.2 means 2 is for testing and remaining is for okay training. So let me show you that as well. Okay, so here again, out of these 8 responses, 8 training. Then let us understand who are the 2 remaining. Anybody has this question, I will be happy to solve. Otherwise, please keep your mic on mute. So here we have splitted our data into two parts. One is first X train part. Then here these are the responses. If you remember these three columns. Now there is one problem. What is the problem here? Is this data does not have a value. Okay, if you remember what is NaN, okay, no value at all. So that is called as missing data. Okay, there is another problem. If you observe that, let me, okay, if you remember the data, there are two parts, okay, where there is no information. One is here in the age and second here is in the salary. So if everybody understood this process, let me go and show you how we can change this. Okay, so first step, please write down or understand whatever we are doing. There are standard processes. First is understanding the data. Second is understanding the libraries that we required, then importing the data and then data processing. So how we do data processing? Okay, I'm going to go for one template that I have. Okay, and don't worry, I'm going to make sure that all of you receives these files as well, because this is a hands-on session. So you will be requested to do this at the end of the day and then revert back if you have any difficulties. Okay, so data processing tool, first importing the libraries that we did, then data set, then we have printed this data set. Okay, it might change again. Then again we have printed X and Y, and what we realize, there are two nans. Okay, means values are missing. Now the next part of the code that we are going to take is into taking care of missing values. So there are different methods, primarily 4, but there are different methods of taking missing value operation handling. So here we are doing taking an average mean value of that. Okay, taking an average of that. Okay, I think I'll. Okay, yes. So here, if you want to replace this value with an average value, then the algorithm says, okay, we required simple imputer. Now what simple imputer does? It identifies which value is missing and replace it with the parameter, the strategy that we choose. Okay, so here if you observe that currently in Germany and Spain, in case of Spain, age factor was missing. In case of Germany, which was missing? The salary part. So what we did, okay, we computed that, okay, and we transformed that. Now we can observe in case of Germany, the value is here. Okay, in case of Spain, again the value is being added. So what, from where this value comes? These value come from the average of these. This value come from the average of these. So this is one method of using a data pre-processing for missing. I'm just covering the basics so that once we go into algorithms, you will not be able to come back. Now, there is a second problem. What was the second problem? If you observe that France, Spain, Germany, okay, all of this is what? This is a specific type of data. Okay, generally what we do, we encode the categorical data. So how we encode the categorical data? We encode using some specific mechanism. Okay, so if you remember, like in the previous session, the madam said that we are replacing by one value, two values, something like that. It is called as hardcode encoding. Okay, so we are doing that here. We are going to change this country column into different parts. But I want all of you to understand this. So what we are doing here, we are encoding them, okay, by different columns. So first part that we do, if you observe that there is a France, there is Spain, there is Germany. Okay, so there are 3 different countries option there. So we create one for France, one we create Spain, and then when we create Germany. And for here, if France is present, we will convert this into 1. Spain is going to be 0. Okay, and Germany is going to be 0. So this is called as one hot encoding. So one parameter is being converted into 3 column. Okay, France 1, Spain is not in this, so 0. Germany is not in 0. So in second column, what will happen? France 0, Spain 1, and Germany 0. The next of the part will be as it is. Okay, sorry, I should write here 44. Since it is float, is 40.0, and this is 7200. So you observe that we have converted 1 to 3 column structure into 6 column structure. Why? Because we were doing encoding of a categorical data. So machine actually encode this. Machine actually encode using one hot encoder. So this is the theory. Let us see practically at the end. Okay. So here I'm doing an encoding. In encoding, observe that this is my result. This is my result. Okay. So we did the first part, since it is Spain. Second part is missing because the first part was free transfer. Okay, so we have created this as a France. Now code to doing that. Let us try to understand this code. So first we do this sklearn.compose function that we use, and we use column transformer. So what is the object of this column transformer? Is to convert one column into 3 columns, 1, 2, and 3. To convert one column into 3 columns. And the process that we are going to use is one hot encoder. So how we do this? See, CT. So CT is probably a name that we give for column transformer, and encoder that we are using is one hot, and okay, reminder is pass through. Pass through means one will be given, and wherever value is present is 1, and remaining value where there is no present is 0, and then we'll transform. Okay, I hope you must have learned what is NP array. Okay, and then this how we have converted this. Now this is the problem. This we do for independent variables. So which variables that we had? Independent country, age, salary. But there is also one part that is called as dependent variable. Okay. Now what we'll do in case of dependent variable? Dependent variable was yes and no, right? Dependent variable was yes and no. So yes and no is again a qualitative data. Machine can better perform in terms of numerical, or in some algorithms like k-means and everything, it is not possible to operate, okay, on textual data. So for that, what we are doing, whenever there is yes, we are going to say it by a number 0 or 1. So here I have used no is 0 and yes is 1. So no is 0, yes is 1. So if you have a data, you can observe that probably. Okay, I'll have to print this before encoding, but it will still be same. So basically what I'm yes.
Screen is not
Hello.
so screens
Hello.
for only you're not able to see further slides.
Okay,
Nothing.
just
Only it is stuck on taking care of missing data only.
yes, I was explaining that, but again I'll share.
That.
Yes, yes.
Yeah.
Just give me a moment. I'll again share. And thank you for your input, so that you know it will be better for me to take care of the problems. Okay. Now can you see again?
Yes, sir.
Okay.
Yeah, it is
so
now
we are
encoding the dependent variable. Yes.
yes, we are now encoding the dependent variable. So how we are encoding? The way method is very simple. Okay. Whenever there is yes, yes will be converted into 1, and whenever there is no, no will be represented as 0. So here this represent that first is no, second is yes. Okay. The method is again sklearn preprocessing. From preprocessing we are using label encoder. Label encoder is used for dependent variable. most of the cases, or it could use for another variables as well. LE is what we have given a name, and we have called this method. Okay, and when we have called this method, we are using LE.fit transform, fit transform y. So fit transform is in terms of Boolean, and this is the logic for it. Okay. So this was the very basic primary part which I wanted all of you to understand. The next part is very simple. We have again transformed the data. Now we have a training data, we have testing data. Okay, so I will not go into again much detail of this. Okay, this is what just displayed. Now feature scaling, selection or scaling that we do. Now what feature scaling and selection that we do? Okay, now if you observe that in our model here, this value is in terms of 0, 0, this value is in terms of 1, this value is in terms of probably around 2 decimal number, and this value is in terms of 5 decimal numbers. So what is the problem? If I try to learn a linear equation, I don't know how many of you are much familiar with the linear equation. So let me just give an example of simple linear equation. Okay. Anybody remember school example of linear equation?
Yes, sir.
Right. So this we learn in school, right? So here y is independent. Okay. X is dependent. M is by what proportion? So we actually teach in school that if this is the curve and then this is the probably slope of that curve, and that slope of that curve is M, right? So this is another constant value here. Okay, and this constant, anybody remember, is shifting from 0 to that particular point. Okay,
Sir, X
so
is independent and Y is dependent.
sorry, X is, yes, X is independent and Y is dependent. Right? So here what we are doing, if I know the X value based on X, based on slope and based on shifting, can I calculate this Y? So basically, if X goes here, 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 can I calculate what with respect to this, what are the values of Y? Right? But now the problem is to calculate this if I keep on adding variables. Means if I say Y is equal to mx probably x1, m1 x1 plus m2 x2, because now there are multiple variables, right? 1, 2, 3, 4, 5, in case 5 variables are there. Then every time this variable value will affect, because the higher value have higher shifting. Higher shifting means if one of the x variable value is by 10-fold, like 38, it will shift from here to directly the extreme point. If it is 52, it will be probably out of the plane. So this is the problem that we face. For that, we do scaling. We standardize them all in one value. Okay. Generally, those who are very much familiar with probability, okay, that is one example of what we do. Okay. And I would tell you one best example that all of you have learned in scaling. Do you remember what we do in logarithm? Logarithm is nothing but scaling between 0 to 99. So we convert all of the values in the world, probably how much higher that value is, and we shift into 0 to 99. And then based on that, we can refer to log table. So here in machine, we try to scale them. If you observe that first 3 values are not changed, the next values are being changed. And how they are being changed? Okay. How that scaling has been occurred, right? So here, let me explain that quickly. First, we have taken 3. Okay, so what this 3 represent and what this 3 represent means, if you observe that in the previous, okay, country, age, right? You remember this was country and then age. Country we have already shifted. Okay, and then there was a salary. So we have taken for all of these. So first 3, probably you can focus on these 2 right now. And how we do fit transformation? So what we do, based on all of the values that have been present, we'll scale it. So probably this is our number line, okay, and this is the central of that, so probably 0. Then I would take the medium value, okay. Generally, those who are more familiar with normal distribution, we generally take Z is equal to mean is equal to median, okay, is equal to mode, and we convert this value using this, and all of these values are being calculated. So this is called as scaling. The function is fit transform, okay, and scaling transformation. Okay, we have just scaling to both training set as well as test set. Okay, now if you see, we have displayed the training set and test set. So this is called as pre-processing. This is called as pre-processing. Everybody's clear? Anybody has any point in this pre-processing so that I can go to the first algorithm? If you don't say anything, I'm going to assume that you have understood. Okay, but definitely if you don't understand any part, I'll be happy to answer it. So the first algorithm that we are going to see is salary. Okay, so simple regression for that. Just a moment, I'll share you the data first. Here, the same data we are going to use for different part. So here we are going to run 3 algorithms on that. I hope all of you can see the salary data set. Let me just, okay. Now again, all of you can create this data set. 1 year of experience and salary. You know, in most of the cases, you will have a question. A company, the case is very simple. A company want to define if we hire a new employee, what should be their salary? I'll repeat. The question case problem is very simple. If we want to hire a new employee based on his experience, what should be their salary? So to do that, what they did, they mentioned every person's in terms of experience in ascending order. Okay, so what company notified? These are the experiments in terms of years, and these are their respective salaries. Okay, so company के HR ने अच्छा काम कर लिया. Okay, now based on this, they come to a data scientist and they ask the data scientist, so ये हमारा data है. अगर मुझे 6.5, I'll repeat, if I want to hire somebody with 6.5 years experience, okay, यहाँ पे, then what should be their salaries? Okay, what should be their salaries? Everybody understood the question, research question?
Yes, sir.
Okay, so shall we solve it? Okay, so we are doing simple linear regression. So the question that we have just seen now, y is equal to mx plus c, we are going to do this. So now importing library. Let me just first do this. Okay, first we'll import the library. So libraries are not changed. Okay, we are going to import the data. We are going to select the complete data other than last column. Okay, as a independent variable, and last column, that is salary, is going to be dependent variable. Okay, then we are going to split this data into training and test set. Okay, then we are going to train the model. Now here, this is the model where we choose which model to be used. Okay, so we are using linear regression from sklearn. We have called one, okay, you can say in instance as a linear regression function, and then we are using linear regression fit method. This is called as fit method. Model is generally based on fit method, and we are passing 2 data set. One is our training data set, and based on training data set, we are trying to find out, okay, whether value or salary of y has been matched or not. Okay, so we'll do that. Now This model has been run. So linear regression function has been executed. Now, if the question is, if I predict, okay, if I predict, then whether how much is my answers are correct. So we have predicted it. But how will I identify whether how much was my result? So let us run a graph. Okay, I am not going to go to the graph syntax right now. I'll just explain you this. So based on these are the year of experience, these are their salaries, and these are those points. Okay, and what simple linear regression does, it tries to divide the data, okay, in equal proportion. So a linear regression model will try to fit a line which could be central to all of these. Okay. Now there are lots of methods. We are going to go for polynomial and everything later, but this is a simple method. So can you observe that most of the data, okay, is near this line. Most of the data is through near this line. So this is a linear regression. Okay. Now let us see how it performs on test data. See, we were able to predict. Okay, what this means? One value we were able to predict exact. Second value we were able to predict exact. Third nearby, fourth nearby, fifth nearby. And there are 1, 2, 3, 4, 5 values which we were not, our test model is not able to predict. So based on that, you can calculate F score, you can calculate accuracy, you can calculate lots of things. Okay, you can calculate confusion matrix as well. Simple, simple. Everybody understood this? Any problem in terms of linear regression? I'm trying to cover up maximum algorithms if possible. That's why I'm going to the next. Anybody have any question? Just let me know. I'll, pause for a moment. Simple linear regression. We imported the libraries. We imported the data set. We done training and testing. This was similar to what we have seen first. Then we use method. Our focus was to use linear regression. So we have used simple linear regression method. For simple linear regression method, we require 2 columns. That's why we have used that data. Okay. And if again, in the next, we are going to predict as well later. But if the salaries, probably I'll show you here. If salary is here 6.5, then from 6.5 you can predict that this salary could come around between 90 to 1000, something like that. Okay, so that also we can do programmatically. So let me go to the next use case. Yeah, I've taken a lot of examples for you. Sorry, but again, I'm going to show you some new data set. Okay, after that, we are going to come back to our original data set. Okay, so this is another type of data set. Now here, there is a problem, Make in India, Startup India, there are lots of things going on, right, in India. So this is live USA data set that we are using. Okay, this is in the year 2015 to 2020, I think. So this is research and development amounts spent in terms of dollars. Okay, these are the administrative amounts spent. These are the marketing spend. This is the state on which this happens, and this is the profit. So these are actually the live data set of 50 startup companies that are started in the year 2015 in the USA, and these are their expenditures. These are their expenditures and state. Based on that, this is how they have profit. They have earned the profit. Their area of working was a little bit different, but our research question is, can we find out, is there any model on which we can identify whether how much these factors will affect the profit? I'll repeat, how much these factors. So what are these factors? Research and development expenditures, administration expenditure, marketing expenditures, defer profit. First, is there any relationship? If there is any relationship, is it linear? Okay, and if it is linear, then can we predict? Okay, so first we'll study that. Everyone is clear with this data set? Okay, let me just again share you. Okay, so our data set. I hope everybody is clear with our first process. So what is our first process? Let me reset everything. Can anybody tell me what we do first? We import the libraries. In most of the questions, what we are importing? NumPy, Matplot, and Panda. Okay. Once we import this library, what we do? We import the dataset, and dataset is going to split into X and Y. X is a independent dataset. Y is a dependent dataset. Okay. Then, if you want, you can see the dataset. See, this is the complete dataset. Now, are we splitting here into? No. Why? Because what we observe in this dataset, New York, okay, is a categorical data, right? Right. So what we do, we were going to first convert it. Okay. So you remember now one hot encoder. So what it does? Can you tell me what it does? See here 0.0, 0.0, and 1.0. So what it does? It observed that currently there are 3 states: New York, California, and Florida. So first is New York, then so 100 probably matrix of identity matrix will be there. So something like that. Okay, so 1 is converted to 3. Then now how many parameters are there? If you observe that the multilinear correlation we are studying, so regression, sorry. So here there is 1, 2, 3, 4, 5, and 6. There are 6 parameters. So x1, x2, x3 up to x6. You might have remember what in the morning Mani has said this in mathematical. So we are using that. Okay. Now training and testing split. Right? Easy. Now we are training the model. Now if you observe that whenever we train a model, whenever we actually train a model, we use the same method. But why this is multiple linear regression? Can anybody tell me? The equation is same, function is same, then why it is multilinear function or regression? Can anybody tell me?
Multiple input variables are there, sir.
Exactly.
More than one.
Here, whenever we selected data in the previous data set, there were only 2 columns. So there was only 2 relationships, 1 independent, 1 dependent. Here, if you observe that there are 1, 2, 3, 4, 5, 6 at the end. 6 independent variable and 1 dependent variable. That's why this is multilinear. Or multiple linear function. Function is done. Now the question is here. Predict the test result. So we'll just predict them. I'll explain this code first and then we'll see the values. So here y predict function says use the regression predict that we have used. And based on the regressor predict model that we have trained on X data set, calculate Y. So if in X test set, probably see X test set has 1, 2, 3, 4, 5, 6 parameters. So based on these parameters, predict based on linear function, predict values. So predict values of Y. Then we are taking precision 2. So we are taking precision 2. Means if we get up to decimal 2 points, we'll stop that. And then after we get this, we are going to, check whether these values that we have guessed or our x1 to x is gives and actual values. So we are going to compare these values with actual values. So if these are our predicted values and these are actual values, and these are actual values from which data set? Okay, y-test data set. So this and this. Generally, what we do, like Ambuja also said, we take the difference of this. So y-test minus x-test. That also we do to identify how much correct we are. But this way, we will go into more and will understand. See, this is very nearby. This is a little bit far. This is too far. If you observe that this value has a large difference. So if I want to plot some kind of linear function, multilinear function, then probably these will be in terms of line. These will be in terms of line, but for this, it will be somewhat x is predicting less in terms of y. So probably this will come somewhere here. So this point will come here. So here in this one case, it is not a good predictor. It is not a good predictor. Okay, so I hope this multilinear function is clear with you. Any understanding problem in terms of multilinear regression? Can we go to the next case, use case? Hello? Anybody can confirm whether you have understood or okay. Now from here onwards, we are going to use the same data. Okay, so we are going to use the same data. So I'm going to show you that data first. And we are going to run 3 different models on that data. Okay. The data is very simple. Okay, just let me share. Okay, now from here onwards, we are going to see a data. Okay, where are only 3 columns we are going to consider. 2 independent, 1 dependent. Columns are what is the position. So these are the rules or positions. These are based on their position, their levels, and then based on this, their salary. And can from position, I can predict the salary or not. If I say another person, okay, with manager level has been assigned, so how much should be their salary? Is their first question, is there any relationship between these two? Whether the relation is there, is it linear? Is it polynomial? What kind of relationship it is? Okay, and based on which best relationship we can fit the model. Okay, so let's do that. We'll be now running different models on this. First model that we are going to do is polynomial regression. Okay, now I am going to go little bit okay quickly because all of you already clear. First, we import the libraries, so no change in that code. Import in data set, no change in that code. We are using the same linear function. Okay, only we are saying that linear function is xy, x comma y, right? So we are changing same. Now we are parallelly, this was our linear function. We are parallelly using a polynomial function. So what is polynomial function? Anybody knows what is polynomial function? Polynomial regression model. Okay, I'll show you, and then I think it will be better to understand the code. So let me run both the visualization. See, a linear function is like this. So in school, we have been taught that linear function is like this. Okay, and this is, if you remember, the function of mod x is a best example for that. Okay, and polynomial function, we say x square. So something like that. Okay, So here, this is a polynomial function that we are currently using. I'm just giving a simple analogy so that it will be better for understanding. Now, based on our value, see, this model does not fit better. Why this model does not fit better? Because in the linear model, if you understand that, okay, only this part, see, only this is fitting, okay, rest of not even near, this is at least near, but these are, this is also a near, but these are little bit far. And if you observe that they are in the curve nature, this is little bit of this kind of curve. So linear model is not suitable, not fitting. So fit is not possible here. So that's why we go for polynomial result. Now, if you observe a polynomial function, okay, it is fitting more accurately. Okay, right? So it is fitting more accurately. Now, we are going to use the polynomial function. Okay, we are going to use this polynomial function and we are going to predict this using linear and polynomial. So the question is very simple. You remember the previous question, if my salary is 6.5, okay, that is position level, what should be my salary? So my position is 6.5. So that my salary is around 330378 is what linear regression says. Okay, and if I use the polynomial function, it says 1,58,000. Okay, observe the large difference in these two, and the difference is why? Because linear will tell me somewhere here I should be get paid, and polynomial will tell me no, I, as level gets increases, the management position gets increases, the salary should increase exponentially. Okay, so here in this case, that's why polynomial regression is more better in terms of fitting. Okay, everybody is clear why we have not using linear function in this and why we have moved to polynomial function. Can we go next?
Yes, sir.
Okay. Generally, higher management people are, like this case study because they can definitely say that now I should get, paid a little bit higher. Okay. Now we are going to use, somebody say SVM. Okay. That is support vector. Okay. But here instead of SVM, we are using SVR. So support vector regression. Now the sequential procedure is same. Now here onwards, okay, we are going to use the same data set for which, okay, we are going to use the same data set for SVR, decision tree, and random forest. Okay. So let me just run this. First, we are going to import the libraries. Then we are going to import the data. Let us see the data. Okay, 1 to 10. These are, if you remember, these are the positions. These are the salaries. Okay. Now what we did, okay, we have reshaped it. What we have just reshaped it, it was been restructured in terms of, okay, length and 1. So length and 1 means 1 column. Okay, so we are just taken into 1 column. Now again, what is the problem? If you see that they are into higher values, so we are just rescaling it. So we are rescaling x and original values of x were 1 to 10. Okay, and values were 45 to, okay, probably 10 lakh or something like that. So we have rescaled it, both of them. Okay. Anybody remember we have done XY correlation regression problems in stats and maths. There we have used this kind of scaling. So minus median divided by some 100 or something value. So that is a rescaling that we did. So all of the values are rescaled. Now we are using SVR kernel. Okay. Let me just train the model The code is very simple. Again, here we are using the kernel is RBF and we are using the fit method. Okay, but our objective is not into that model. Our objective is to how the value has been predicted. So first, let me just tell you. See, in polynomial, we were getting some 1,50,000 salary, right? Okay, my SPR model suggests me to pay that particular person with 6.5 a salary of 1,70,000. A salary of 1,70,000. Okay, do you want to see how it performs? Let me show you. Here, this, okay, this performed this, and still this is better model. Can anybody tell me why? Okay, now let us consider the example of Microsoft or any big MNC. Okay, higher the position will be paid very high value. Okay, probably a person who is at the very low cost rate will be paid very low value, but they does not represent uniformity of the class. The middle management will be the best sample to solve it. And if you observe that this, okay, even though it does not fit exactly, this understand this, and this is called as outliers or probably those who are not fitting. Okay, in mathematical part, we call them extreme values, and we try to avoid this value, and that's why this is the comparatively better model in terms of this. This is the comparatively better model in terms of this. Is this clear? So in data, you should also consideration how your data speaks. And based on that, let me show you with the smooth curve. See, it will this, it will not try to, like polynomial function was trying to cover this point as well. It will not try to, cover this point. Sometimes it is called as misclassification. Sometimes it is called as misclassification.
Can we call it as overfitting problem, sir, previously in polynomial
Yes.
case?
Yes, yes. Definitely we can call it was overfitting.
Yeah.
Because
That
it
is
was not supposed to be taken care, by
extreme
machine.
cases.
To be
Yeah.
considered from our objective. We should have removed those extreme cases initially and then started, for modeling.
Yeah.
Okay. So next we go for, okay, SPR decision tree. Regression. That's why I'm trying to present different cases and different algorithms so that it will better in terms of understanding. See, coding, I would suggest you have to practice. There is no alternative. But if you understand how function performs on simple one cases, it will be better. I just clear out the output first. So the next case is decision tree regression. Okay. I hope everyone is familiar with the decision tree. Currently, my purview is not going to much of the theory part, but if anybody does not know decision tree, just let me know. So again, we have done the same thing. We have imported the libraries, we have imported data set, we have trained the decision tree model. Okay. And now we are predicting the value for 6.5. Now it is coming again lower. So what was happening in case of SVR? It was giving very high value, 1.70 something. Okay, now here it is reducing my salary. So higher management person would say, I should not follow this method. But let us try to understand what it performs. Do you remember step function? Anybody mathematically remember step function? This, what it does. So decision tree is considering a certain values from one level to another. Okay, so decision is made not at the point, but at particular level. So if you observe that, if this is between somebody can you mute? Yes, thank you. So this, if A is the case, this decision will be taken. If B is the case, this decision will be taken. If C is the case, this is. So based on these cases, okay. And now, even though person is of higher management, that can also be considered. So if the person is of higher management, let us suppose a CEO joins your organization from some another company, then that will also be considered based on the level. So this is a better fitting model, which is not overfitting anything as well. Okay. Is everyone able to grasp the concept? Yes, sir. Okay, so that's why here it still consider this value, considering it is required in terms of data. It considers this value. It does not makes it outlier, okay, or extreme values, but it understand that for this position, this is required because CO could be judged, right? But since he's being paid higher, does not mean all of these salaries should go into higher values. Not on a linear, not on a polynomial. Okay, so based on that, this won't happen. And if you say SVR will somewhat go from here to here, it will just consider them into different steps. Okay, and tree is been formed. So if you observe that actually, I don't know how many of you know this, but if value is less than 6, then this will happen. If out of this value is less than 4, this will happen. If out of this less than 2, this will happen. So this kind of decision trees will taken where the value will be predicted. Okay, so I have just drawn one simple tree for you, not that much accurate, but to give you an idea. Okay, so this was a decision tree. Okay, I want to show you one more that is very famous. Okay, anybody know what is random forest? At least a concept. Multiple decision trees. Absolutely. But why it performs better than decision tree? Anybody knows or something like that? It is like a forest connection from start to end. Okay. Avoid the overfitting. Sorry.
It is giving best fitting decision tree probably.
Let's see. Okay. So I'm going to run again a simple importing a libraries, importing a data set, then I'm training the data set, and now I'm predicting a value. Now the value is 1.67. Okay. It was 1.50. Now the value is 1.67. Let us see how it performs. So like somebody rightly said, decisions tree, multiple trees as a forest. So can anybody observe and comment anything? Would like to comment? Okay, just let me explain. Here, the random forest algorithm does what? Okay, it also use the decision model to divide. Okay, but if you observe that there are more decision trees or more kind of decisions have been taken. Okay, so in mathematical part, the decisions have been taken in more manner first. Okay, second, it considers still this should not be considered. Why? because there is no in between associated value. There is no in between associated value. So it also after a certain, so there is a, decision making algorithm says after a certain, if the point does not lie, it left the point. So probably here there is no point here, so it won't go further classifying. So technically this is going to be the end of that. It will try to fit maximum points, but avoid overfitting. Clear? So here, what was the previous part? First, it was linear. So let me try to connect this. Okay. Then there is a polynomial function. It was something going like this. Okay. Then there was SVR. SVR is going like this. Okay. Then there was decision tree. It is very difficult because it will override, but it will try to accompany this point as well as the end. And then lastly, random forest. It will do like, if you remember, I have drawn a decision tree. It will try to go into more minute levels, as well as it will try to classify them in a more appropriate manner based on their weight. Okay, and their presence. So that's why decision tree using random forest gives the more accuracy, but it is not always true that you should always follow this. Okay, only this format only. Okay, but currently, yes, random forest gives the better performance compared to others. I think my first use case has just ended now. So I'll go to another use case. Just let me share you one data. Before going further, let us have 1 minute brainstorming. Can anyone tell me what you have understood from this? Can anybody tell me what you have understood from this? Where you can apply this if possible? Okay, so let me share you the next set of data. You can think and you can let me know the cases you can apply. Okay, now the next data is very simple. See, there is a marketing firm. Okay, marketing firm has conducted a survey. They are launching different products. Okay, they have mentioned the user IDs. They have taken the user's gender. They have taken user's age, their salary, and based on that, they have mentioned whether the person has purchased or not. See here, the salary was 1,50,000 probably. So the person has purchased that product. Okay, here again the salary was not up to the higher level, but still these has purchased. So company does not able to formulate which age group we should target or which salary we should focus on, or based on if I get at least these parameters. Okay, now see, user ID is not a parameter. So consider at least if you get these 3 parameters, can we predict whether the person, okay, will buy that product or not? Okay, and the next cases that we are going to see are lively implemented. If you want to see whether they are being lively implemented, go to any of the shopping site like Amazon, Flipkart, everything in the backend, or even a Google, Facebook, they are actually using these. So they have your data, and based on your data, they are actually doing the same thing. Okay, but instead of salary, they might have your previous purchase record or something like that. Okay, so don't go into exact fields right now, but try to understand how they are doing it. Okay, what is the best use of data science in terms of these? Okay, so the next is logical regression. In logical regression, I am going to directly go through that. Okay, now here we are only going to use the 2 values for now. Can we do multiple? Yes, we can do multiple, but we are using only 2 columns. See, that is okay. So we are using only based on gender and age. Okay, we are first going to identify based on gender and age. If the person, okay, gender is probably male or female and their age is so and so, can we predict their decision only based on these two factors? Okay. Now let me just clear all the outputs. Yes. So first we imported the libraries. Again, we are not doing lots of, see, I have taken a lot of efforts to identify in minimum set of libraries, minimum ways, how you can understand more and more algorithms. So we have split into data. Since what was the problem? Okay, why we require feature scaling? Can anybody tell me why we are using feature scaling in this? Where we require feature scaling? Try to recall the data. In case of X test, we required where decision has been purchased or not. And in case of X train, in case of gender, we require that, right? Okay, so let me go further. Okay, let me train the model here again. This is called as classifier. So currently we are now moving to different segment. Now we are identifying classifications. So this is, even though it is called as logistic regression, it actually does classification. Okay, how? Let's see. Okay, now we are taking classification prediction. So what we are doing right now? Okay, we are, let me show you the confusion matrix. So we are predicting now. Okay, what this means? Okay, this means that, see, okay, probably I'll say X, Y, X and Y. Oh no. See, I wanted to, I have predicted that the person will purchase. Okay. I have predicted that person will purchase, and from data, yes, the person purchased. Okay. Then we have predicted that the person will purchase, but not purchase. Okay. We have predicted that the person will not purchase. Okay. But the person has purchased it. And we have predicted that the person will not purchase and the person has not predicted, not purchased. So technically these two are correct. Okay. So if you calculate them, 65 plus 24 is 89. So we were able to classify 89 as correct, and 8 plus 3, 11 were incorrect. So this is correct. This is incorrect classification. That means out of 100 cases using logistic regression, 89% of the times we can correctly classify this. Okay, now let us see this by graph. In terms of training, this code, again, I'm not going to go into much right now. If you don't understand any part, just let me know as well. Okay, now this is the best part. Here, see, this is the logical regression. So here we have shifted into these two. Okay. Based on salary and age, here now we were able to predict these many. So these, okay, are correctly classified. If you see, there are some red in between. These are not correctly classified. They are been deviating, and they are probably, if you count, they should be 11. Okay, so this is a training set and test set. See, so their classification is much higher. Now here 1, 2, 3, 4, 5, 6, 7, 8. Probably there is some 9, 10 something in between. So here these are the logistic regression classification. Everybody understood this? Anybody who does not understand any part? So what we are doing here, we are using this data, we are classifying that correctly. So probably the left hand side is not purchasing and right hand side is purchasing. Currently here it is reverse, but understanding. So, and this is our line of classification. This is our line of classification, and it classifies 89% of the things accurately. It classifies 89% of the things accurately. Okay. Shall I show you one more case? This is the most interesting part. Okay. Now, first thing that we are going to do is again import the libraries, import the data set. Data says feature scaling. Okay, now here we are training the KNN model. We are training the KNN model using the K neighbor classifier. We are using the K neighbor classifier. Now here we are saying whenever there are 5 values nearby, okay, use it. The metric to identify that particular value is based on, okay, Minkowski algorithm. So if you want to learn more, you'll have to identify how it identifies that part. Okay, and we are using P as 2. So this, I'll have to go just a moment. I'll just show you that. So again, we have done the classification. Now we are going to see the confusion matrix. Now, if you observe that using K nearest neighbors, our accuracy, or I would not say exactly accuracy, our predictive part has been increased to, okay, 64. Correctly, we have said that they will purchase, they have purchased, and 29 we said they will not purchase and they have not purchased. So around 93 we were out of 193 we were able to classify correctly. Out of 193 we were able to classify correctly. Now we are going to visualize the training set. Okay, let us try to understand that. Just a moment. Okay, see, this is a way KNN works. So based on this, we have created this cluster. And since we were saying P2 partitioning 2, here we were saying P2, they are being divided into 2 parts. Okay, and in these 2 parts, probably based on this kind of curvy, okay, loci, we can actually, classify them better. So this is a performance of KNN on training data. Let us see how it's performed on test data. I repeat, these data sets are very simple, very basic, only to give you the understanding of every use case. But you can go to Kaggle, you can go to Google, and you can download a different data set, and they will perform, wonders if you keep on doing it. See, in case of test data sets, the same classification gives us the better result. These probably 3 are being misclassified like we had in the previous one. And these 4 here, these are the 4 here. Able to see the cursor, I don't know. So just let me mark this. So here 1, 2, 3, and here 1, 2, 3, 4. Only these 7 are misclassified. These 3 where we want to purchase, but not purchase, and this here we said that they will purchase. They will not purchase, but they have been purchased. Okay, so these are the only 7 out of 100. So probably 93. Sorry, classification is correctly. Okay, so this is a performance of KNN algorithm. Okay, nearest clusters. Now, I'm going to show you few more examples, and then we are going to see the case study that we are going to give you to you. Okay, using k nearest neighbor. Let me keep it here itself. Okay, now somebody say SVM. So let us see how SVM performs on this. Now I'm going to just run everything. Okay, and I'm just going to show you that, because it will be very difficult for me to, run and execute each and every time, and the rest of the part is going to be same. Now for next 5 cases we are going to use the same, only the algorithms are being changed. Okay, now let us see on the same model without tuning hyperparameters how SVM performs. So SVM, again, we have imported the libraries, we have imported the data set, we have split the data set, we have used the feature scaling, okay, for standardization. Then we have trained the model, we have predicted it, we have calculated the confusion matrix. Instead of KNN, this models, okay, gives 90 as accuracy. It was 93. Correct classification here. Okay. If you observe that this 66 is, okay, reduced, 24 is as it is, right? And here this misclassification has been increased from 3 to 8 by 5. Okay. How it performs, let's see. This is a SPM classification on training. This is a SPM classification on testing. Okay. So this is SVM. Okay. Third, kernel SVM. There is one more thing here. Okay. I'm just going to now quickly go through all of the results. Again, we imported the library, we imported the data set, we have split the data set, we have used feature scaling, we have trained the SVM model, okay, using kernel RBF. Okay. Then see, this is a confusion matrix. There were 5, you remember 5 misclassification years. They have been shifted. So now SVM with kernel gives me smoothly a little bit different curvature compared to KNN, but gives me the same performance. It gives me the similar level performance. This is on training data. This is on testing data. Okay. Now let me go to the another algorithm. Okay, naive. Okay, naive is is based on Bayesian algorithm. Okay. Wait, again, imported library, imported dataset. So I'm going to skip this scaling and training. Okay, let me go to the direct confusion matrix. Here, this precision accuracy and this precision accuracy has been increased, but still it is 90, okay, out of 100. And how it performs, see, similar to kernel SPM in smooth curvature nature. Okay, right? And on the test data similar. There are few, if you observe that there are 1, 2, 3, those who are on boundary. But if you try to cover them, it might go into overfitting as well. It might go into overfitting as well. So I'm not going to do that. Show you another. Now decision tree classification. And same data set, only algorithm has been changed. Okay, wait, let me go to classification. Now, if you observe that the first value has been reduced, the second value has been increased, and these two are approximately limited, but instead of 90 now it is 91. So 1%, chances are being increased. But see the decision tree classification. It classifies based on the clustering, or you can say some kind of, structural part. So this is kind of a clusters that have been formed using tree structure or tree classification. This is on training set and this is on a testing set. So this is decision tree classification. This is decision tree classification. Next we'll see random forest lastly, and then we'll then I'm going to ask you one question. Okay, again, random forest, the answer is again 9. Here they have been classified somewhat every time same, but here that has been increased a large, and this is how a random forest does compared to decision tree. A little bit different structure, but these are the decision models. Okay, these are the decisions on which it has been taken. Okay, and this is on training and this is on testing. Okay, is everyone able to see this? I'm going to show you all of this again, and I am going to ask you a very simple question for which I am not going to answer. I'm just going to ask you the question, which algorithm is best? Okay, let me show you all the results again. I want open answer from all of you. You can put in chat box. If you're not comfortable, you can orally give me, that's fine. Okay, I'm not taking a poll, but first, KNN algorithm, the performance is this. If you are not understanding, please write down 64,4,329. Okay, SVM. Okay, the classification is 66 to 824. Then kernel SVM 64,4,329. Naive base 65,3,725. Decision tree algorithm 62,6,329. And finally, random forest 63,5,428. The question to all of you from all of these use cases, can anybody tell me which algorithm is best and why?
Random forest.
Okay, random forest. Sorry?
It will not do overfitting.
I couldn't hear. It has?
It will not have overfitting.
It does not have overfitting. Okay. Let me show you graph for all, and then you can decide. Anybody else has any other opinion?
It's SVM.
SVM. Okay, why? Okay. Anybody else has any other opinion?
In HPM is 66 to 8 and 94.
Okay, based on values. Okay. Anybody else has any other opinion? Okay. That's fine. Later as well. In the meantime, I just wanted to show you something. We have thinking on giving you one simple assignment. Okay, and for that assignment, okay, I think Dr. Ambuja ma'am has already explained you, okay, some part. So here, let me show you that. I think you must have seen the data set, right? If not,
Yes,
let me just quickly share you the data set as well. Let me just share my complete screen for some time. Okay, first, let me start with basics. Original data set that we have collected in our research is somewhat like this. Okay, you can observe that there are some special characters, there are some missing values, then there are lots of things which are there which should not be there. Okay, if you can observe there are some missing values, then there is colon, right? Some syntaxes are not accurate or something like that. Okay, so some things are always present. So first thing that we did is based on current things that I have explained to you. Okay, we have done cleaning. So madam has, taken a lot of care and it takes a lot of time. Okay, to create a clean data. And generally in research, it is very difficult to have a data. So after cleaning that, only there was some questions in terms of headers. Okay, but most of the data has been cleaned. Okay, and this data we are going to provide to you. Okay, so this data part 2 database, okay, we are going to provide to you. So what you are supposed to do, I am also going to share you, okay, this. Okay, just let me go. Okay. Studying not yet. Yes. So we are going to provide you with this data. We are going to provide you the, code as well. So what we want you to change this data set, okay, in that algorithm. Okay, we want you to change this data set in that algorithm and try to execute and identify which algorithm is performing what. Can I change the parameters? Can I implement different parameters? How is that been classifying? Okay, currently here we have taken column number 2 and 3. So if I see the data set, I'm seeing this is column number 0, 1, 2 and 3. Have you shifted to your home? I'm just taking this feature. And do you take sufficient health care? Based on these two problems, if I implement this, how the clusters are being formed and what is the accuracy? Currently out of probably 51, 1 and 6. So 62. Okay. Currently out of 0, there are a lot more than that. We are taking us very small features. See, only 55 are being correctly identified, but still 55 out of, okay, 62 is a larger number. Okay, and this is how it has been visualized in terms of training and testing set. Okay, so probably these 5, there are 5, right? So these 6 or 1 are being misclassified. So here there are 6 and out of 6, 1 is gone there. So this is 5. So these might be misclassified. Rest of them are, correctly classified. Since the data is larger, it is not showing in that graph. You'll have to fit it. Okay, that's why these are all errors. So I'll repeat. We are going to provide you with this data. We are going to provide you with this as an example KNN code. You can experiment using different codes. Now there is one thing. Let us suppose if I use this data for SVM, how it will perform. If I use kernel SVM, how I will perform. If in this, probably in this, if I change the parameter, let me take all the parameters. Okay. What will happen, whether it will run, if it will run, what will be its performance. Okay, see now I have taken for X all the columns. Here there are total 51 columns. If I select from here to here, as you can observe, there are total 52 columns, but out of 52, first is number, a registration number. Okay, recognition number. So we are going to ignore that because that should not be an independent variable and that should not also be dependent variable, right? So out of these, if I take other than last column, how my model performs. Okay. See, this is another type of clustering that will happen, but confusion matrix is not changed. Okay. So you can see how it performs in terms of training and testing. You can change different columns. So the question was which features you want to select, and based on which feature you want to calculate that. Currently, we have selected a last column. So what is the last column? This last column is your area. But if instead of that, if you want to see a profession, okay, then you can select this. So it will be -3. Make sure that you have some another value here, and then how they perform. So we want you to be a researcher doing lots of things. We don't want you to, stuck with the code. Instead of that, we want you to use the different codes which are available, try to understand which are algorithm, and whenever you implement the algorithm, see, now this is a better, okay, matrix, and then you should be able to understand for which feature we are getting which error and something like that. Okay. And this is some kind of classification that we are taking. So currently we have 14 clusterings and 14 errors, and this is on training data. So we want you to play with this code. Generally, you won't get first-hand research data set. Sorry. So we are going to provide you with the first-hand research data set in terms of COVID Corona. Okay, we are going to give you the sample coding structures as well. You can use any of this, and that will, help us to do the research. Okay, is this clear to all of you?
Yes, sir.
Okay, great. Now just give me a moment. I'm going to show you some part. Last part, how you can do that, because I know lots of students who are, are similar to my students who I teach. See, this is one example which I'm going to show you on Corona. Okay, the data set which we are going to print. So here, first, I have shown the data set. In the data set, we have added some headings to identify that. Then we have, for example, here there was one data. What? How much % of your daily routine has been changed due to Corona? How much percentage of your daily routine has been changed due to Corona? And percentage vary from 0 to 100. So we have taken 4 classes whose, probably daily routine has been less than 25. So we have ignored that. Not ignore exactly. So we have distributed that. And then 25 to 50, 50 to 75, 75 plus. And then based on that, I'll just go. We have shown different classes. Then we have taken 2 questions. So do you think preventing Corona by social distancing will work? And have you shifted to your hometown or some other places due to pandemic? Based on these 2 features or parameters, can we predict? Can we predict how much % of their life is changed? Okay, because see, when you think that there is social distancing work, you will socialize yourself or distance from others. And when you think that you have shifted to another place, again, it will affect, okay, your daily routine, right? So based on these 2, for an example, we have considered it and see, okay, we have divided it. So what we have divided, technically, we were able to calculate groups. So out of 25 to 55, okay, percentage group means out of 25 to 55 who think that their age group has been shifted. Okay, 48 things that social distancing will work, and 48 think that they have shifted. Okay, those who say higher, okay, there are some who say yes, around 75% my daily routine has been changed. Their number is more higher, and those who say I have probably very high effect in my daily routine, around 75 plus, their number is also higher. And those who say less than 25%, Okay, my life has been affected. There are only 8. Okay, and we have, demonstrating it, okay, in terms of percentage. So generally, basically, this has been just given to graph. But the next part that we have done for you to understand is shifting out of 50, 48, 25 to 40, 50, 48 things that shifting is important and socializing is important, or answer that in a positive manner. Okay, so then see, we have taken one funny example, like Madam has said, that whether data say something, but it is all right to use that data in that manner. So here we are thinking that based on the weight change. So for example, let me go to the next part. See, weight change. So if your weight has been reduced, increase same as before and not check whether that affect your percentage of daily routine. So based on that, we have drawn this graph and we were able to find out that those who are in between, okay, 50 to 75, who say that my routine has been changed, their weight is same as before is very higher. There are 75% of people who say that my daily routine has been changed. Their weight has been increased drastically. And there are people who say my daily routine has not been changed. If you observe that their weight has been reduced. Okay, so these are the funny ways through which you can actually play with the data, and at the end we have calculated the correlation as well. So I think I have almost completed my time. If you permit me for a few times, I would like to show you some more use cases and then we'll stop.
Yeah, we can also ask Mukul sir, like by attending the FDP, how much weight you have gained? Yeah, we can have some questions also. You want to show something more?
Yes, sir. Actually, I wanted to show you only 2 parts which are related with this, and then I'll like to stop.
Okay.
Because madam has not able to see the PCA. So I want all of them to try PCA, kernel PCA, and cross-fold validation. Only these 2 cases.
But I think it's like it will be better if we take some questions, because you have shown a lot of models.
Sure.
So let them assimilate it, let them consume it first. Otherwise, it will
Yes.
be a large number of models you are showing, so it will skip all models. So let us stick up to it.
He did extraordinarily good job.
Thank you.
And let us check if participants have any questions, whatever models you are. If anyone have problems or any have some queries or question, doubt, we have an expert with us, model experts. All right. So I think you can share the code and the data set.
Sure.
You mail me so that I for all participants the instructions are like this one. So I'm going to
It is mailed to you in the morning.
Ambuja madam is there. She said the data has been already mailed to you in the morning.
Okay, fine. So the code.
I'll share the code. Sir is asking me to share the code. Yes, sir. Joshi sir, I'll send you the code as well. All the code files.
Fine. So the instructions for the participants is like I'm going to upload this on the ATAL portal. So on your individual login, you can see these documents. The code will be there. The data set will also be there, and you can change the dependent variable, independent variable, and it's like playing. And it's like
Yes.
people used to say, chemistry people are lucky; they can just have to change the chemicals and they get something out of it, and we computer scientists are not so lucky that we have to do the basic research. But this machine learning also helped us to do such type of parameter tuning and this playing with the parameters attributes. So you can choose any parameter as an independent variable, dependent variable, no bar for that. and just want to get insight of the data. So this is a very good exercise both Ambuja madam and Dr. Mukul has given to us. So I think we can just play with that. Everything is there. The data is there, the code is there. We have to just apply it, and then we have to get it. So maybe may I request you, Mukul, like you can just write a short sort of steps to reach to the Jupyter Pi, so that they can also, that will also be helpful to them. So you can give a Word file in which you can give the steps to reach to that particular place. Most of them have installed Anaconda yesterday, but it will be fine. It will be better if you can give the steps also. Okay, great.
Sure, sir.
Yeah, thanks. So that's all for today. Let us stop today. Tomorrow we have the 3 sessions, and again there will be let me just give you a brief idea about the sessions. It's like we have talked about multiple regression, linear regression here, but there is one more concept that Ashish Tendulkar also demonstrated, is a neural networks. Deep learning is one area which is very much picking up, and we have a very good resource person to talk on deep learning tomorrow. Then we have these many applications of machine learning are there. Application in art, like in Bharatanatyam dance, how machine learning can be helpful. So that lecture will be there, and how people are using it in health domain also. So that is an application of machine learning will be demonstrated to you. And one person is a young student from Luxembourg will be joining us tomorrow. He's a very enthusiastic guy, very prominent person, student, and he's doing PhD there. He has his own startup over there. He is going to talk us about data visualization. So that all 3 very good sessions are coming up. So I request you to join right time, because in this 3rd session we see some people who are joined little late. These 5 days, this FDP should be our priority. AICT is helping us, so we should also cooperate. So thank you all, and have a great day ahead. And I'm posting, so whenever you get time, upload the output also, so that we can share it with Mukul and Ambuja, so that they can come up with some interesting facts also. Thank you very much. Have a great day ahead. Thank you. Bye.